All right, so subclaim B then takes a little bit of a different cut on things. Subclaim B still involves mathematical content, still involves a connection to the standards for mathematical practice, but it's called additional and supporting content. So you're going to see content under subclaim B that is in addition to what you've just taught, you know, the stuff in A, to the important stuff. So there are some new topics. But more importantly, and this is where you want to really look at that horizontal coherence of the Common Core, that internal coherence, how the topics are connected, that this is also content that supports student understanding of the subclaim A topics. So let's take a look at some examples and see if we can make sense of what that means. In 6th grade, subclaim B. Now remember, 6th grade subclaim A did a whole lot with fractions and multiplication and whatnot. So in 6th grade subclaim B, you'll see that one of the major areas there is factors and multiples. Certainly that's connected to the content we talked about before. Geometry, statistics and probability, and that would be all for subclaim, or subclaim B for grade 6. So if we look at this factors and multiples, what we see is that for all children, we need to find the greatest common factors and the least common multiples. That will be something that all kids will have to do regardless, and will have to demonstrate understanding of, regardless of their performance level. Where things change is that as I move from level 2 to level 5, I'm doing more things with respect to factors and multiples. Level 3, I'm rewriting the sum of two whole numbers using the distributive property. Level 4, I'm going to use it use the distributive property as a multiple of two whole numbers with no common factor. So in level 3, I have the common factor. In level 4, I don't have a common factor. And then, and if you notice too, in most cases they use that, but I may not use that all the time. And then in level 5, I am using it consistently. So what you see there is the content is not changing terribly significantly. We've got that introduction of the distributive property for level 3, and then the use of common versus no common factors. But what's happening is how often I use that, whether or not I use it consistently. And that's the connection to the standards for mathematical practice. And that's that rigor. So how do I get kids to do that more often? Well, I have to make sure that I'm assessing them for that, to understand who's using it and who's using it consistently, as well as then providing them learning opportunities to use them and to see the rationale behind them. All right, so then in geometry, what you see there is not a great difference between the different categories, levels of performance rather, on this page. But as you dig into the geometry, what you'll find is the use of formulas by students who have a higher level of command in terms of finding unknown measurements, not just finding the volume, but maybe I know some of my measurements and I know the volume and I'm trying to find the missing measurement. As well as then students who are at the distinguish command in geometry solve unstructured or complex problems. And we're going to see that come up again. As kids are performing at that higher level, they tend to have a better fluency with complex and non-routine, I guess we could say, problems as well. And part of that, I think the reason for that, there's two. Certainly, those kids who are performing at a higher level may have more tools in their toolbox to do that, but I would argue many times those kids are able to do that because we actually ask more of them on a consistent basis. So it kind of begs the question about whether I am asking my students to do that in a way that's actually giving them that opportunity to develop that skill, rather than having those non-routine problems be something that's so out of the ordinary. Subclaim B for 7th grade should wake you up, because remember, we spent most of our time with subclaim A in 7th grade talking about proportionality and using unit rates and so on and so forth. 7th grade subclaim B really takes and tries to encompass a lot of other content, additional content. It can be supporting if you look at it that way, but this representing geometric figures really involves this idea about uniqueness in triangles, about understanding, slices when you decompose or cut apart a three-dimensional figure, what different face can result and what different figures can result. And most importantly, when you're studying the standards to teach in 7th grade, what you need to understand is that the geometry that you teach in 7th grade is of absolute critical importance to the geometry that they will learn in high school. And if a child leaves 7th grade and does not have a good command of this representing geometric figures, particularly the conditions involving triangles, when do I make a unique triangle? When do I make more than one triangle? When do I make no triangle? And can I construct triangles with those conditions? If I leave 7th grade and I do not have a strong command of that, I'm going to really struggle through high school geometry. High school geometry has changed significantly. And if you're a 7th grade teacher and want to know more about that, certainly I will be addressing that in my next session when we go through the geometry performance level descriptors. So representing geometric figures is the first area. Then drawings and measurement, as you see there, involving 2- and 3-dimensional objects, including composite objects. Then the last two that are of note, that's another big shift for 7th grade, is this idea of randomness, random sampling, and comparative inferences, which many 7th graders haven't ever learned because it's really been moved from high school, as well as chance processes and probability models. As hopefully the Common Core has moved probability and does not appear until 6th grade. Most of that is because kids aren't developmentally ready for it until they're in 6th grade. The understanding that chance has no memory is very, very difficult for young children to grasp. So kids will be coming to you in 7th grade having just had their initial exposure to probability in 6th grade. And so you have to take that and kind of ramp it up and start with this probability models as well as these comparative inferences and random sampling. So those would definitely be some of the subclaim content that I would study carefully, especially the comparative inferences. And when I can say that there are differences between two populations, when can I assess the degree of overlap between two data distributions, and a 7th grade unit on probability sampling and comparative inferences and simulations is going to be extremely important for those students. Subclaim B for grade 8 then takes what we started with subclaim A with the algebra kind of notions and continues that with looking at rational numbers and modeling with functions. However, there are two other topical areas in 8th grade for subclaim B that you'll want to pay attention to, and that's volume and bivariate data. Now, if you have children in the first couple years of the new assessments with the PARCC assessments who have not had a successful experience in 7th grade with that random sampling and statistical inferences, then you're going to have to go back and fill in some blanks, because this bivariate data stuff is going to be much more difficult, especially linear association and models of best fit, if children haven't had a good experience in 7th grade. So you want to look at that. But let's look at a couple of pieces on this to look at some of the differences for subclaim B in 8th grade between the different performance levels. Again, as we've talked about before, but just to hit home on this a little more, between this level 2 and 5 under rational numbers, there's a whole lot that's the same in terms of understanding what numbers are rational and irrational, distinguishing them among them, and putting them on decimal expansions, actually generating their decimal expansions and putting them on the number line. That's something that cuts across all 4 performance levels. What's different then is kind of, taking things to the next level in terms of repeating decimals, in terms of terminating decimals, and fractional representations of those rational numbers. So we need to be sure that we don't just say, here's a rational number, here's an irrational number, let's put them on a number line. What we need to do in order to help kids achieve at that level, aim for that level 4 and 5, is to really help them dig into some of that rational number understanding at the big picture. Looking at patterns, looking at structures of repeating decimals, and having them draw some conclusions based on that, and then make some predictions. If I know some things about 3/7 and 1/7 and 2, or if I know some things about 1/7, 2/7, 3/7, and look for patterns, what could I predict would be a decimal expansion of 5/7, so on and so forth. So then this modeling with functions, then you can see that we move. This is a really good example to look at, especially as you look at the algebra stuff for 8th grade in particular. You'll see a real difference in terms of the kind of representations that are used. That is absolutely connected to those standards for mathematical practice. So you notice for level 2, I'm modeling a relationship between 2 quantities, and I'm going to construct a function from a table or a graph. Now I'm going to model it, create a function in a relationship without a context. So it's more of that abstract algebra kind of situation. And then now I'm talking about with or without a context in level 4, and that's the same for level 5. What you see then underneath this at the very bottom of this page is how the children's understanding of rate of change changes as well. So now I'm going to determine the rate of change and the initial value from a table or a graph that contains it. So that's pretty rote. That's pretty low level in terms of it's there, it's apparent. And so now I'm just given 2 values in a table or a graph for level 3, and I have to determine it. And so I'm not given it, I've got to figure it out. And then, but that's still in a table or a graph. Then in level 4, I'm just given, in 5, I'm just given that description, and I have to create and I have to create the initial value and the rate of change. So that's a big change as kids move from levels 2, 3, and 4, and so on and so forth. So in summary, so far, subclaims A and B have to deal with content and the marriage of those mathematical practices, and you'll see those interwoven. But there are also some performance level descriptors that are very much content focused, especially in the algebra area, where we then get into really pulling out those mathematical practices are in subclaims C and D. So let's start with C and see what it looks like.